Okay, so here are your notes on how to graph linear functions. Your learning target, or your learning target, is to be able to graph linear relationships from an equation, a table, and a verbal description. Okay, so your first one is from an equation specifically. Your first equation is y equals 3x minus 2. So if you remember, that would be your slope, that would be your y-intercept. So if I draw my axes, there's my x-axis, there's my y. My slope is a 3, so positive 3, and I can put it over 1. It's nice to make it a fraction because then you know your rise is 3 and your run is 1. You want to start with the negative 2. You want to start with your y-intercept. So I'm going to go down 2 because it's a negative on my y-axis because it's my y-intercept. And that's where I start. You always start with that negative 2. From the negative 2, that's your first point, you go up 3, over to the right 1 because they're both positive. So 1, 2, 3, 1. Technically, you only need 2 points to make a line, but remember you can continue in that same pattern of up 3 over 1. That slope will continue for the entire line. If I were to draw this line, it would continue down in this direction. This is a positive 3 and a positive 1. That would be the same thing as a negative 3 and a negative 1, because I could reduce that and come up to a positive 3, positive 1. 2 negatives would make a positive. So not only can I go up 3 to the right one, I can also go down 3, like that negative 3, to the left one. And that continues in that same line. I'm going to try and connect them. Don't laugh, it's bad. Okay. And just kind of a double check. That's a positive slope. Uphill. Yeah, that's a positive slope. Okay, let's look at the next one, number 2. So remember, you always want to start with your y-intercept. I'll do my x and y axis. And you can put these wherever you want. If you have a really big or really small y-intercept, you can kind of change this. So I need to go up 4 on my y. 2, 3, 4. And I went up because it was a positive 4. I'm doing it on my y because that is my y-intercept. And I started from the origin when I did my y-intercept. Now I go to my y-intercept and I do negative 2/3. I'm choosing to look at that as a negative 2 and a positive 3. If you would prefer, that's equal to or the same as a positive 2 and a negative 3. These things are all equal. So because of space, I'm going to go down 2, so a negative 2. And if I'm choosing to do the negative 2, that means I have a positive 3. So to the right, 3. I only need 2 points technically. Here I would run out of room, right? I'd have to go up 2 over 3. It would be kind of here. Here I would have to go down 2, positive 3, kind of here-ish. Oh gosh. And then just try and connect the point. Hopefully better than I did. Should be a negative slope. That's negative. I'm good. Alright, so the next one. You always start with your y-intercept. So I'm going to start with a negative 3. I'm also grabbing the sign in front of that y-intercept. So I'm going to go down 3. 1, 2, 3. Make a point. And then from here, from this point, I'm going to do my slope. You don't really have a slope here. It doesn't look like it. But remember, there's a 1 there. And also remember, like up here, if you want to make something into a fraction, whatever the top number, whatever the numerator is, you can just put a 1 on the bottom to make it a fraction. So I'm not putting a 1 on the bottom there because there's a 1 here. I'm putting a 1 on the bottom here because I always will put a 1 on the bottom to make a number into a fraction. Alright, my slope is positive 1, positive 1. So from my y-intercept of negative 3, I'm going to go up 1, over 1. up 1 over 1. And I could continue going up 1 over 1. I could also go down 1, left 1, right? That would continue that line. So that's just saying positive 1 over positive 1 is the same thing as negative 1 over negative 1, because the two negatives would cancel and get me positive. I'm going to try and connect those dots. Okay, should be a positive slope. Yep, that's going uphill, positive slope. Just kind of double checking. Okay, the next one is a little bit different. So there's two ways to think about this. This is saying y equals 4. Something I want you to notice here, you only have one variable. You only have a y. If you only have one variable, it's going to either be a horizontal line or a vertical line. We talked about this a little bit last class. If you have y equals 4, go to where y equals 4. I know that seems silly, but try. 1, 2, 3, 4. This has no x value. So no matter what, y is always going to be 4, no matter what point you pick. All of these points, like this point right here, is over 1, 4, right? That's 1, 4. That's 2, 4, 3, 4. Negative 1, 4, negative 2, 4, negative 3, 4. All of those points are on the line y equals 4. So if you have a y equals some number, you're going to have a horizontal line at that number, just like that. Okay? So the next one is kind of similar. This is weird because there's only one variable. There's only an x. The only time you have a horizontal or vertical line is if you have one variable. I'm going to put in my x and y axis. Try to. This is saying x is always negative 5. So 1, 2, 3, 4, 5. X is always negative 5. Right here, my point is negative 5 on the x, 3 on the y. Negative 5 on the x, 2 on the y. Negative 5 on the x, 1 on the y. Right? All of these would have an x of negative 5. And that's all I care about. They don't tell me what y is. So if I have an equation where x equals some number, you know automatically it's going to be a vertical line at that number. So those are two kind of weird situations, and I don't want you to get them confused with this third. I made a big deal in trying to have you remember that horizontal and vertical lines happen when there's only one variable. This looks different, but it has two variables. When you have two variables, it's just like how we started. You're looking for a y-intercept and a slope. If I start with my y-intercept, there's no number here. No number is really just a 0. So when I go to graph a y-intercept of 0, oh my goodness. When I go to graph a y-intercept of 0, hopefully I do a better job with that. Your y-intercept is at 0. So right here, I'm not going to go up or down at all on the y-axis. That's my first point. My slope is 3 over 1, right? I can make it a fraction. So I'm going to go up 3. 1, 2, 3 over 1. Remember, 3 over 1 is the same as negative 3. Oh, I'm sorry. Over negative 1. Right? That's the same thing. The two negatives make a positive. So I could also go down 3 to the left 1. There's my point. Oh my gosh, that should be a line. That is an ugly line. It's a positive slope. It should be a positive slope. Okay, things get weird here. Everything I've given you so far has been either x equals or y equals. it has to be in y equals mx plus b. Sorry, I keep hitting a button on my pen. For the whole way that we're graphing to work, you have to have a y-intercept, you have to have a slope. This is not in y equals mx plus b. To put it into y equals mx plus b, I'm going to have to divide everything by 2. That will cancel, so I'll have a y. That does not cancel, and I'm not going to make it into a decimal. That's my slope. That's the coefficient of x. So I'm going to leave it as a fraction. Negative 12 divided by 2 will get me a negative 6. I have y by itself. I have a number in front of x. I'm good to go. So my y-intercept is negative 6. I probably do not have room. 1, 2, 3, 4, 5, 6. I should have thought about that better, huh? And then my slope is up 5 over 2. So 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5 over 2. And I can connect those, and all set. So just remember, it's got to be y equals mx plus b to be able to graph it, unless there's only one variable, unless it's x equals some number or y equals some number. Okay, this is even more different. This has the x and the y on the same side. My first step is to get rid of the 2x. I'm going to subtract 2x from both sides. So I have negative 3y. I'm going to run out of room, I'm sorry. Equals 15 minus 2x. I'm going to divide everything by 3. Excuse me, a negative 3. So I have y, because the negative 3's will cancel. 15 divided by negative 3 will leave me with a negative 5. Negative 2, negative 3. I want to leave this as a fraction because it's my coefficient of x, it's my slope. But 2 negatives will make a positive. So positive 2/3 x. I can now graph that. One thing I want to make sure you're okay with, though, is that you're going to have to look really carefully for your slope and your y-intercept. This is in a different order. This, negative 5, is your y-intercept because it's by itself. The 2/3 is your slope because it's in front of x. It's the coefficient of x. So I'm going to start at negative 5. 1, 2, 3, 4, 5. And go up 2 over 3. You can try this, and I'm going to kind of run out of room. And that's my line. I had to make it y equals mx plus b. I had to make it slope-intercept form first. Okay? Alright, I really feel like the next 2 learning targets are review from past years and even some this year, so we're going to go a little bit faster through those. They're asking you to graph from a table. If I'm given a table, or even just 2 points, I would plot the 2 points, or plot the 3 points that they're given to me, and then I would connect them. So 2, 6. So I start at the origin, I go over 2 because that's my x, and I go up 6. And I'm going to run out of room, I'm sorry. And then I have 4, 7. So over 4, up 7. And I need to be better at looking at where I'm kind of going. There, to put my axes. Excuse me. You only need 2 points to graph a line. So you can just graph those first 2. You can plot those first 2 if you want. Okay. The next one. 1, 3. And my y's are going to kind of get big, so I'm going to move my axes down here. My axis. My y-axis. I'll just leave right in the middle. As close to the middle as I can get. Okay, so my x is 1, so I'll go over 1. And then y is 3. And then 2, 5. And this is a point, so I always start at the origin. 2, y is 5. Start at the origin because it's a point, it's not a slope. 3, 7. There's my line. I did 3 that time just because I wanted to. I could only do 2 if you wanted. Okay? That's all you need to do for that. Alright, your next and your last learning target is to be able to do this from a verbal description. So this says, Kim and Cindy are starting a business tutoring students in math. They rent an office for $400 a month and charge $40 an hour per student. Graph this function. Okay, so I first have to decide what is my x and y axis going to be. If I'm doing $40 per hour, I can think of this per as kind of like a fraction bar. So I have 40, oh my goodness, I'm sorry. I have $40 in 1 hour. So you can either think, okay, this is my rate of change, this is my slope. Slope is the change in y over the change in x. That means money is going to be my y, and time in hours will be my x. Another way to think about it is you can think of which one is independent and dependent. Independent, right, would be the time, would be the hours. Dependent would be how much money she gets for that time tutoring. Okay, so if I'm going to start at $400 a month, right, and if they're renting this, if they're renting it for $400 a month, that means that they're starting every month by paying that bill. They have no money and they're paying a $400 bill. That means that they are going to start, I'm going to have them start here, at negative 400. Okay, that's their first, if hours are 0, they've tutored no one, they're at $400. Every time they tutor somebody, every time they tutor for an hour, they get $40 more. So I'm going to go over 1 hour, and let's make this 40. So if they have $40, they're going to have negative 360. Then it will be negative 320. The money is increasing as time continues. Okay, so your next one, the last one, oh, and I'm sorry, I'll talk about range and domain down here too. If 6 kids come to your birthday party, you'll need to buy 4 pizzas. If 10 kids come to your party, you'll need to buy 6 pizzas to feed everybody. Graph the function. Okay, so my independent variable is the number of kids that come to the party. I'm going to go up to 6. So I'm going to start at 0, 1, 2, 3, 4, 5, 6, 7. I'm going to stop at 8. Oh, I'm sorry, because I'm looking at kids. So 10 kids. Let's see if we can even get it. 6 kids and 10 kids. 8, 9, 10. So the number of kids you invite will determine how many pizzas you need. This will be pizzas. So 0 pizzas, 1, 2, 3, 4, 5. Let's stop at 6. Okay, so I'm just going to plot these 2 points. If 6 kids come, you'll need 4 pizzas. Okay, so 6 kids, 1, 2, 3, 4 pizzas. If 10 kids come, you're going to need 6 pizzas. Alright, so 10 kids, 1, 2, 3, 4, 5, 6 pizzas. I only need those 2 points to make a line. I'll just connect them. There's my graph. What's the domain? So domain, remember, are the x values. So in this case, that's the number of kids. So in the real world, do you agree you can't have negative number of kids coming to your party? You have a bunch of kids. but not negative number of kids. So your domain will be all positive, right? You don't want negative. Integers. I have to say integers because you can't have fractions or decimals when you're talking about people. Okay? So all positive integers. Oh, that's for pizza. Sorry. Oh, right. Okay. So what is the range? Remember, range are the y's. So in this case, it's the number of pizzas. This would be similar. We're going to say that we're going to order these pizzas. So we can only order whole pizzas. And I can't order a negative number. My range would also be all positive integers. And integers just means numbers that aren't decimals or fractions. Okay, so your homework for tonight, what you'll have a homework check on next class. It's, oh, I didn't write it down, I'm sorry. It's going to be S6. I'm pretty sure this is on your notes. S6 and S19 on IXL. If you have questions, please come see me.